In this video, we will be talking about solving right triangles using Sohcahtoa. What is Sohcahtoa? Let's begin with what we already know, the Pythagorean theorem. We learned that the Pythagorean theorem is used to find the side lengths of a right triangle when two side lengths are given. It is represented by the equation a squared plus b squared equals c squared, where a and b represents the legs that form the right angle, and these are the shortest sides of a right triangle, and c represents the hypotenuse, which is the longest side and is always across from the right angle. We will take this information in trigonometry. In trigonometry, we will state the relationships of the sides and angles of a triangle by writing useful ratios such as sine in symbols sin, cosine in symbols cos, and tangent in symbols tan. To help us establish those ratios, let us look at this right triangle CAB with the given acute angle B. Let's label the parts of the triangle first. We will call the side opposite the given acute angle B as the opposite. The side across the right angle is the hypotenuse, and the remaining side is the adjacent. The first trigonometric function that we will establish is the ratio of the sine function. We will use opposite over hypotenuse, and to remember this ratio, we will use the acronym SOH, or the SAW. The next trigonometric function is the cosine. The ratio is adjacent over hypotenuse, and the acronym that we will use is the CAH, or the CA. The last function is the tangent, and the ratio for tangent is opposite over adjacent. The acronym that we will use is TOA, or the TOA. Let's use the Sohcahtoa to solve a right triangle. Let's solve for the missing side of this triangle. First, let's label the picture. Opposite is the X, the side across the given acute angle, which is 40 degrees. The hypotenuse is the side across the right angle, which is 18. And the remaining side is the adjacent, which is the Y. To solve for X, we can use the sine ratio because X is the opposite, which is what you are trying to find, and the hypotenuse is given. So we can set up our equation as sine 40 equals X, which is the opposite, over 18, which is the hypotenuse. And then to isolate the variable, we will multiply both sides of the equation by 18. And this will allow us to cancel out the denominator. So we have 18 times 40 equals X. At this point, we will need our scientific calculator, and we have to make sure that our calculator is in degree mode. Let me pull up the Desmo scientific calculator. So make sure that you are in degree mode. So we will type in 18 times sine 40, which is equal to 11.57. We can round out the 11.57 to 11.6. Now, let us solve for y. In this case, if we want to utilize the value of the hypotenuse, then we can use the cosine ratio, or the CA. So, cosine 40 is equal to y, which is the adjacent, over the hypotenuse, which is 18. We will multiply both sides by 18 to allow us to cancel the denominator 18. So we will have the new equation 18 times cosine 40 equals y. And then again, we can use our scientific calculator and making sure that the calculator is in degree mode. So we will have y equals 13.8. Let's have another example. Let's solve this triangle. First, we must label the parts. The side across the given acute angle, which is 62 degrees, is 14, and that's going to be our opposite. And the side across the 90 degrees is the hypotenuse, which is dx. And the remaining side is the adjacent, which is the y. If we want to solve for x, then we must use the SAW, or the SOH, which is sine equals opposite over hypotenuse. So we'll have sine 62 equals 14 over x. To isolate the variable, we multiply both sides by x to cancel out the denominator x. So our new equation is x times sine 62 equals 14. Then finally, we can divide both sides by sine 62. And again, this is the time to use our scientific calculator and making sure that they are in degree mode. So we will have x equals 14 over sine 62, which gives us 15.9. And to solve for y, we can use the tangent. We multiply both sides. We'll use the TOA, which is the TOA. We'll use tangent 62 equals 14 over y. And to solve for y, we can multiply both sides by y to cancel out the denominator, and we'll have y times tangent 62 equals 14. And dividing tangent 62 on both sides, we'll have y equals 14 over tangent 62. And putting this in our calculator, we'll have y equals 7.4. To summarize what we learned today, in trigonometry, we can express the relationships of the sides of the triangle by setting up the ratio of the two sides. Using this ratio, we can find the missing side or angle of a triangle. We use the basic trigonometric functions, sine, cosine, and tangent. The sine theta is equal to opposite over hypotenuse, which is the SAW. Cosine is the adjacent over hypotenuse, which is the CA. And tangent is opposite over adjacent, which is the TOA.